fundamental theorems of calculus, there are two, the first and the second. First, we discussed what's called the fundamental theorem of calculus, simply the first fundamental theorem of calculus, if you will. And what it says to us is how to evaluate an integral, that the integral can be evaluated by some method of simplification of the integral or the antiderivative, and then we can get the results of the so-called definite integral by evaluating the results of the integral by the difference of the upper limit of integration minus the lower limit of integration, where those numbers are evaluated within the so-called antiderivative. So, without hesitation, the fundamental theorem of calculus, if f is a continuous function on some closed interval from a, b, and capital F is said to be the antiderivative of f, that is that the antiderivative is the result of the integration of little f. And so we can evaluate the results of this integral in terms of the difference of f of b, where b is the upper limit of integration, minus f of a, where a is the lower limit of integration. What happens to the terms in between a and b? Well, they're actually summed and minused out, if you will, through a series of summations. And so the emphasis here that we end up with would be the first from the last. Somewhat of a telescoping method, where that which is in the beginning is essential and that which is at the end gives us the summed up value for the so-called integral. Well, let's look at some problems. The instructions say evaluate the integral, use the graphing utility to verify your results. No need to use a graphing utility. We'll just work these problems directly. So here we integrate. This 8 is seen as 8 times the integral of dt, so this gives us 8t. This is evaluated from -3 to 1. So this becomes 8 evaluated at 1. Then this is minus 8 evaluated at -3. So we get 8 plus 24. And here we get 32. Okay. So what about this one? We evaluate or integrate. So the integration, and if we can do that all together, I don't know if you understand that, but let's see if I can help you. So we integrate the 7 dt, and then we integrate the -3t dt. So we get 7t minus 3 over 2 t squared. That's the integral. Now the evaluation here at from -1 to 2. So here we have 7 times 2 minus 3/2 times 2 to be squared. Now it becomes minus. Now we're going to evaluate at the -1. So this is minus 7 times -1. And this becomes minus this -3t, because in the formula it calls for minus then the terms f evaluated at a. So here we're evaluating at -1, so this becomes a minus the 7t, of which we have this minus 7 times -1. Then it's minus this minus, that's positive 3 over 2, and this is -1 to be squared. So this gives us 14 minus, this is 4 divided by 2 is 2, times 3 is -6, plus 7, and this is plus 3 over 2. So this gives us 1 plus 14, we get 15 plus 3 over 2. So that gives us 33. all over 2. Okay, let's see. So before we integrate, we simplify what we have. So you FOIL this out. 2t minus 1 times 2t minus 1 is 4t squared minus 8t plus 1 dt. Now you integrate there, so we have 4t to the third divided by 3 minus 8t squared all over 2 plus t. This is evaluated from 0 to 1. We can simplify, however, so this is 4 over 3 times t to the third minus 4t squared plus t, evaluated from 0 to 1. So we plug in t to equal to 1, so that gives us 4 over 3 times 1 to the third minus 4 times 1 squared plus 1. Then it's minus everything here evaluated at 0, so minus 4 over 3 times 0 to the third minus 4 times 0 squared minus 0. So we have 4 thirds minus 4 plus 1. So this gives us 4 thirds minus 3. So we get 9 minus 4. Alrighty, so negative 5 over 3. So that gives us, let's see here, we FOIL that out, that's 4t squared, and then it's 2t times a 2 is 4t, not 8t. Dag blasted. Well, that goes out the window trying to FOIL in your head like me, right? So 2t times 2 is 4t, and this is 4, and so 4 divided by 2 is a 2. So we have a 2 here, 2 there. So this is 4 thirds minus 2 plus 1 is 4 thirds minus 1. That gives us 4 minus 3, which is 1 all over 3, 1/3. That's better. Don't make the same mistakes that okay, anyway. So we're going to simplify this. This is the integral from 1 to 4. And this is u over the square root of u. Then it's minus 2 over the square root of u du. We simplify that again. This is the integral from 1 to 4. Now u divided by the square root of u is just u to the 1/2. This is minus 2 times u to the negative 1/2 du. So now we integrate. We do not hesitate. We, yes, integrate. So integrate the u to the 1/2. That's u to the 1/2 plus 1. And then divided by the 1/2 plus 1. So this is u to the 3/2 all over 3/2 minus 2 times u to the negative 1/2 plus 1 is 1/2, and that's divided by 1/2. And here we're evaluating from 1 to 4. We clean that up. This is 2 over 3 times u to the 3/2. And this is minus 4 times u to the 1/2. Evaluated from 1 to 4. So here we have 2/3 times 4 to the 3/2 minus 4 times the square root of 4, and then minus 2/3 times 1 to the 3/2, and this is minus, this minus becomes plus 4 times 1 to the 1/2. So this 4 is 2 to the second, so that becomes 2 to the second to the 3/2 is becomes 2 to the 2's cancel out, 2 to the third, so that's the 8. So we get 8 times 2 is 16 over 3, minus 4 times 2, minus 8, minus 2/3 plus 4. So we clean that up. We get 16 minus 2, that's 14 over 3, and this is minus 4. So we get 14 minus 12, 2/3 is what we're hunting for. All right, well, what about here? This integral, we're going to simplify. So this is the integral from -1 to 1. This is t to the 1/3 minus 2 dt. So we integrate. We get 2 to the 1/3 plus 1. That gives us 4/3 divided by 4/3 minus 2t. Here, this is evaluated from -1 to 1. So we simplify this, clean that up. So this is 3/4 times t to the 4/3 minus 2t. And t is evaluated from -1 to 1. So we plug in now, t to equal to 1. So we get 3/4 times 1 to the 4/3 minus 2 times 1. Then it's minus 3/4, and this is -1 to the 4/3 minus this minus becomes plus 2 times -1. And so here we have 3/4 minus 2. Now this -1 to the it's the 4th power first, and then it's the cube root of that. So -1 to the 4th power is 1, and the cube root of 1 is 1. So this is still minus 3 over 4 minus 2. So the 3/4 cancel out. All we have left is just -4. Okay. So hopefully everything is fine. Let's see. Look at this. This is neat. Now you can write this as the square root of 2 times the integral from 1 to 8, and this is x to the -1/2 power. Dx. Okay. The square root of 2 is a constant, so you can pull that out in the front of the integral. And then this is downstairs the square root of x, so we bring that up and write that as x to the -1/2. Now we integrate. So this is the square root of 2. We have x to the -1/2 plus 1 is 1/2. X to the 1/2 divided by 1/2. Here the evaluation is from 1 to 8. So this is 2 times the square root of 2, and then times the square root of x. That's evaluated from 1 to 8. So we have 2 times the square root of 2 times the square root of 8, then minus 2 times the square root of 2 times the square root of 1. So this is 2 times the square root of 2, and the square root of 8 is 2 times the square root of 2, and this is minus 2 times the square root of 2. So we get 4, then the square root of 2 times the square root of 2 is 2, so we get 8 minus 2 times the square root of 2. Okay, one more down here. We're going to simplify. So this is the integral from 0 to 1. This is x over 3 minus, I'm going to write this as x to the 1/2 over 3 dx. So we integrate the individual terms. So this is x squared over 2 times 3 is 6 minus x to the 1/2. The 1/2 plus 1 becomes x to the 3/2, and this is over here 3, and this is times the 3/2 downstairs. That's evaluated from 0 to 1. Let's clean that up, if you will. So this is x squared over 6 minus, this becomes 2/9 times x to the 3/2 power, evaluated from 0 to 1. So we have 1 squared all over 6 minus 2/9 times 1 to the 3/2, and then minus the terms evaluated at 0. Obviously, you don't even have to evaluate the terms at 0 if you know that part will equal to 0. So we get 1 over 6 minus 2 over 9. LCD is 18. 6 goes in 18 3 times. 3 times 1 is 3. And then 19 goes in 18 2 times. 2 times this 2 is 4. And all we have left is negative 1 over 18. Well, hopefully this is okay. And we'll come back and look at the second fundamental theorem of calculus.